This is section 4.7 on applied max-min problems. So they're word problems where we're trying to maximize or minimize some quantity. Okay, so here's the assignment. Looks like the highest we have to go to is problem 37. Show them to you. So page 336 and 337. Looks like where we're starting. Page 337. So that should give you 3 through about 9. Or 11. 11 is kind of long there. Okay, then on the next page, we have to go up to problem 37, it looks like. And there's 37. Okay. Okay, problem 4. The sum of two numbers is 16. X plus y is 16. X and y are both positive. We're trying to minimize the sum of the squares, so we're minimizing x squared plus y squared. So y equals 16 minus x. So f of x is x squared plus 16 minus x squared. We're trying to minimize this. F prime of x is 2x plus 2 times 16 minus x times negative 1. Clean it up. It's 4x minus 32. F double prime is 4. That's greater than 0, which means on a graph, we would have a concave up situation, which means we have a minimum. Set f prime of x equal to 0. 4x minus 32 is 0. X equals 8. So the numbers are 8 and 8. So the sum of the squares of this is 128, the minimum amount. Number 8. X times y, the area is 1,000 meters squared. We want to minimize the perimeter, which is 2x plus 2y. Okay. So from here, y is equal to 1,000 over x. So p of x is 2x plus 2y. Here's y. 2x plus 2,000, x at a minus 1. We're trying to minimize this quantity with x greater than 0. First derivative is 2 minus 2,000, x at a minus 2. Which comes out to be this. Double prime is 4,000, x at a negative 3, which is 4,000 over x cubed. That's greater than 0 for all x greater than 0, which means we will have a minimum at a critical point. So I set p prime equal to 0. 2 minus 2,000 over x squared equals 0. Multiply both sides by x squared. Factor out of 2. X squared minus 1,000 is 0. X squared is 1,000. So x is the square root of 1,000 or 10 radical 10. We don't need a plus or minus. This word problem, we only allow for positives. Y is 1,000 over x, so 1,000 over radical 1,000 is also radical 1,000, or 10 radical 10. So the dimensions are 10 radical 10 by 10 radical 10 meters, which means, of course, you end up with a square. Okay, problem number 11. This is the picture, x by y. The area is x times y. We have 1, 2, 3, 4, 5 this way, and 2 y's this way. Excuse me. So we have 5x plus 2y equals 750 for the fencing. A little bit of algebra. Y is 750 minus 5x over 2, or 375 minus 5 times x. So the area is x times y, x times 375 minus 5 halves x, or 375x minus 5 halves x squared. We're trying to maximize this quantity. So first derivative is 375 minus 5x. Double prime is negative 5. That's less than 0. Which means I have a concave down situation on a graph, which means I have a maximum. So set a prime equal to 0. That comes out to be x is 75, y is 187.5. So the dimensions are 75 feet by 187.5 feet. That maximum area is that times that, which is 14,062.5 feet squared. Okay. Now just for going back, so I'm going back and doing 4.525, y equals this thing. The domain is all real numbers, intercept is the origin. Symmetry, f of negative x is the opposite of the original, so we have origin symmetry. In case you're wondering, The denominator cannot be 0. This is always positive, so we're never going to be dividing by 0. In behavior, limit is x approach to infinity of the quantity, divide top and bottom by x. So it's a limit is x approach to infinity of 1 over radical 1 plus 1 over x squared. That's 1. So y equals 1 is a horizontal asymptote, and y equals -1 by symmetry is also a horizontal asymptote. Okay, the first derivative, bottom times derivative of the top, which is 1, minus the top times the derivative of the bottom, 1/2 x squared plus 1 to -1/2 times 2x. All over the square of the denominator is just x squared plus 1. 2's cancel out there. So I have radical x squared plus 1 minus x times x squared over radical x squared plus 1 over x squared plus 1. Multiply top and bottom by radical x squared plus 1. This is x squared plus 1 minus x squared over x squared plus 1 to the 3/2 power, which is 1 over x squared plus 1 to the 3/2. That's always greater than 0. So the function's always increasing, never decreasing, and therefore there's no max or min. Now for the second derivative, it's best to look at this. So double prime is -3/2 x squared plus 1 to the -5/2 times 2x, which is this thing. Set that equal to 0. That means the numerator is 0, which means x equals 0, or 0 is 0. Okay, and a simple sign chart, if I plug in a negative, this will be positive. This quantity is always positive. So the sign is completely determined by the numerator. Plug in a positive, you get a negative, and plug in a negative, you get a positive. So the function is concave up from -infinity to 0, concave down from 0 to infinity. So the origin is an inflection point. So here's the graph. Odd function, always increasing, concave up, concave down, origin is here. So problem number 25. We have a circle center of the origin of radius r. So I call this x and I call this y. This by symmetry is 2x and this is 2y. So I'm trying to maximize the area, which is 2x times 2y or 4xy. A little bit of algebra. Y is radical r squared minus x squared. You can do that pretty simply. So the area function is 4xy. X line between 0 and r. Okay, so a prime product rule, first times the derivative of the second, 1/2 r squared minus x squared to -1/2 times the derivative of the inside, -2x, plus the second times the derivative of the first. Derivative of the first is 4, set that equal to 0. Okay, a little bit of touch up over here. So this is -4x squared, that 2 cancels that, over radical r squared minus x squared, plus 4 times radical r squared minus x squared equals 0. I bring this over, and then I multiply both sides by r squared minus x squared, so that's gone. That times itself just becomes r squared minus x squared equals x squared. 4's cancel out. R squared over 2 equals 2x squared divided by 2. X squared equals r squared over 2. Square root property, x is r over radical 2. And why do the work is square root of r squared minus x squared is r squared over 2, which means y is also r over radical 2. So that's x, that's y, but the dimensions, you have to double this. So it's 2 of these, 2 over radical 2 r by 2 over radical 2 r. That's radical 2 r by radical 2 r. Okay, 4.7. Find the point closest to the origin. So y equals 2x plus 3. The square of the distance is delta x squared plus delta y squared. In this case, it's just x squared plus y squared, but y is 2x plus 3 squared. So I'm trying to minimize this. So f prime is 2x plus 2 times 2x plus 3 times 2 by the chain rule. A little bit of touch up, 10x plus 12. Double prime is 10, that's greater than 0, which means I will have a minimum. Set f prime equal to 0, 10x plus 12 equals 0. X is -6/5. Plug back in for y, since y is equal to 2x plus 3. Plug in and y is 3/5. So the point is -6/5, 3/5. Okay, 15, you have a box, square base, open top, surface area is 1200 centimeters squared. Maximize the volume, which is x squared y. So 5 faces have an area of x squared for the bottom and 4xy for the four sides. Okay, so solve here, y is equal to 1200 minus x squared over 4x. From here, since the volume is x squared times y. So v of x is x squared times 1200 minus x squared over 4x. X cancels out. V of x is 300x minus 1/4 x cubed, and I'm trying to maximize that with x greater than 0. So v prime is 300 minus 3/4 x squared. Double prime is negative 3/2 x. That's greater than 0 for all x greater than 0, which means I will have a maximum. Set v prime equal to 0. Set this equal to 0. Multiply both sides by 4/3. 400 minus x squared equals 0. Factors into 20 plus x, 20 minus x. Forget the negative, so x is 20. Plug back in. Y is equal to 1200 minus 20 squared over 4 times x. Comes out to be 10. So my dimensions are 20 centimeters by 20 centimeters by 10 centimeters. Volume is 4,000 centimeters cubed. 14 is similar. The volume is 32,000 centimeters cubed. You try to minimize the surface area, which is x squared plus 4xy, minimizing this. Okay, so y is 32,000 over x squared. Plug that in here. A of x is x squared plus 4xy. That's x squared plus 128,000 over x. And you try to minimize this and finish the rest of that on your own. Okay, and then let's see. 4.513, going back to 4.5, y is equal to this. So the domain is all real numbers minus a set consisting of -2 and 2. Intercepts is the origin. Symmetry, f of negative x is the opposite of f of x. So I have an odd function, I have origin symmetry. Asymptotes, when x goes to infinity, y goes to 0. So horizontal asymptote, y equals 0. Vertical asymptote, x is plus or minus 2. Okay, y prime. Bottom times derivative of the top, which is 1, minus the top times derivative of the bottom, all over the denominator squared. It comes out to be negative x squared minus 4 over x squared minus 4 squared. This is always positive, this is always negative. Okay, so the function's always decreasing wherever it's defined. So that's decreasing from negative infinity to -2, union -2, 2, union 2 infinity. It's increasing nowhere, no maximum. Double prime is kind of messy. Bottom times derivative of the top minus the top times derivative of the bottom, 2 times x squared minus 4 times 2x. All over the square of the denominator is x squared minus 4 to the 4th power. Negative, 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 make them all positive. And let's see, factor out a 2x. There's a 2x here and a 2x here. Take that out. There's an x squared minus 4 for both of them. So this leaves you with a -1, x squared minus 4. Plus 2 times x squared plus 4. A little bit of cancellation here. 2x times x squared plus 1 over x squared minus 4 cubed. Set that equal to 0. That happens only at x equals 0. And we have to put down plus or minus 2 also. All right, so 0, -2, 2. Plug in -3. This is always positive. So plus, 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 plus. A -3, that's going to be negative, and -3, that would be positive. Whole thing is negative. -1, that's always positive. That's negative. That's negative, so the whole thing is positive. +1, positive, negative, so the whole thing is negative. And 3, everything is positive. So negative, positive, negative, positive, concave down, concave up, concave down, concave up. So f is concave down from negative infinity to -2, union 0 to 2, concave up from -2 to 0, union 2 to infinity, and inflection point at the origin. So here's the graph. Like that, like that, like that, like that, always decreasing. Concave down, concave up, concave down, concave up. Right, so that was mostly 4.7.